Lesson 1-3, Evaluating Limits Algebraically, Part 1. When you're finished with Part 1, you need to go to Part 2 before the next class. Alright, previously, you were on the internet looking at Kelly's tutorials number 1 through 3. Then in class, we worked through links number 1 through 6. All of this is to help you understand the concept of limits. To review, before I show you how to do limits algebraically, I want to review this concept. Alright, the limit as x goes to c of f of x does not depend on the value of f of c. Where f of c is the y value. And that's because when you're taking a limit, it's read as x goes to c or as x approaches c. You're looking at what the function does as x approaches c, not what as x equals c. So as x approaches c is the y value approaching some y value from the left and from the right. And if that's the case, then the limit exists, and it's that y value. To show you this graphically, I'm going to draw a function f of x. Has a deleted point in it, and this deleted point has an x value of c and a y value of b. Now the limit as x approaches or goes to c of f of x is equal to b, even though f of c does not exist. Now that's because when you're taking the limit as x goes to c, you're only looking in the neighborhood of c. And if as x goes to c and you look to the left and you look to the right, and the function is going to the same y value from the left as to the right, then that is your limit. And it's b. Okay, let's look at another example. Another f of x. Just a little different. I'm just making these up. It's a function. This is c. And it has a y value of b again. And I'm going to plot some point here when x equals c, and that y value is d. Now the limit as x goes to c of f of x is still equal to b, even though f of c is equal to d. Because again, as you look at the function, as x goes to c, you're looking just in the neighborhood. As x approaches c, what is my y value doing? And it's going to b, and therefore that's the limit. Okay, now we're going to look at it algebraically. What happens algebraically? If the limit as x goes to c of f of x equals f of c, then you can evaluate this limit by direct substitution. Then you can evaluate this limit by direct substitution. And I'll give you an example of that. Say you have the limit as x goes to -1 of a simple function, 4x. It's a linear function. If I substitute in -1, I'm going to have 4 times -1, which is equal to -4. That's the limit. Let's take a look at this graphically. Okay, y equals 4x goes through the origin, also has the point, -1, -4, -4, there's -1, plot it, when I draw it, looks something like that. So f of -1 equals -4, when you substitute it in, it's a limit. As x approaches -1, your y value is approaching and even equals -4. Okay, so let's do some other examples. Before I start these examples, though, in your book on page 59 are properties of limits. It's down at the bottom of the page. You need to look at those properties, but I'll refer to them as I go through some of these examples. Okay, number 1. The limit as x goes to 3 of the product of two functions, x squared and 2 minus x, a quadratic times a linear. I'm going to use substitution. You should always try substitution first. When I substitute it in, I get 3 squared times 2 minus 3. Now the properties of limit says that if you have the product of two functions, the limit is the value of each one, is the product of each value. So it would be 9 times -1 equals -9. So you just substitute in, multiply it, and that's the limit. On that function, it's actually a cubic. When x equals 3, y is -9. Number 2, the limit as x goes to 0. This is the sum of 3 terms that form a quadratic. And the property says that you can substitute in and add and subtract each value. And you have the limit for the entire function. And there it is. Okay, what about a constant function? 5. If you think of f of x equals 5 or y equals 5, it's a horizontal line. The domain is all real numbers, so it doesn't matter where x is going. And in this case, x is going to -3. The y value, or the output, is always equal to 5. All right, how about a rational function? The limit as x goes to 2 of x squared plus 2x plus 4 all over x plus 2. The properties again say that if you have a quotient and you put the substitute in, so you have 2 squared plus 2, okay, slowing down here, 2 squared plus 2 times 2 plus 4 all over 2 plus 2. You just evaluate it as you normally would. 4 plus 4 plus 4 over 4, which is 3. So that's the limit. Alright, just a couple more of these. Number 5. The limit as x goes to 2 of the square root of x plus 3. Substitute in, square root of 2 plus 3, root 5. This is easy. One last one. What if you have a composite? X goes to -2. You have 3x plus 1, linear function inside a squared function. Substitute in, square it, that's -5 squared equals 25. So if you were to graph that on your calculator, 3x plus 1, quantity squared, you went to the table, input -2, you're going to get an output of 25. Alright, this is the end.